Here's a diagram illustrating the Earth's atmosphere to scale, and they do a good job of showing you how thick each of these layers of the atmosphere are, starting with the troposphere down in the red, getting higher into the stratosphere in yellow, mesosphere in green, eventually getting up into the thermosphere, and then the exosphere in purple at the very top. So you can see pretty much all weather occurs in the troposphere. You can see how thin of a layer it is around the Earth. If I zoom in on this, make it a little bit easier to see, they actually have the different elevations in here. The troposphere going between 8 and 15 kilometers up. Why the range? Well, the range exists due to the temperature of the troposphere. Where it's colder at the poles, you only go up about 8 kilometers. Where it's warmer near the equator, you will be around 15 kilometers before you get to the top of the troposphere. As the troposphere changes into the stratosphere, they call that the tropopause, that boundary line where it goes from red to yellow. And then the stratosphere extends up in a similar fashion up to 50 to 60 kilometers, again depending on if you're at the poles or the equator. Then you end up with the stratopause, the boundary between the yellow and the green here, and then the mesosphere 95 to 120 kilometers up, and then the thermosphere, which to scale is the thickest of the layers, but really isn't too much up there at this point. The density of the air is very, very low. Not a lot of molecules going or bouncing around out there. The majority of the molecules, due to the force of gravity, are found down here in the troposphere. Here's another diagram taken from Wikipedia. This one is not to scale, but it kind of gives you a relationship as to where you see certain phenomena in the Earth's atmosphere. So starting at the bottom, you can see how you have contrails, those trails of condensing water vapor that you see from airplanes sometimes. At the lowest levels of the atmosphere, really, 6 to 12 kilometers up. When they send weather balloons, they get to about as high as 40 kilometers. But really, most of the clouds that you see in here are probably within 6 to 12 kilometers up, and some of the lower ones are even below 6 kilometers. But as we work your way up through the atmosphere, the ozone layer is located here in the lower portions of the stratosphere, and you get a lot of the meteors burning up by the time they get to the top of the stratosphere. Any aurora that you see are generally in the mesosphere and thermosphere, and you get all the way up here. The International Space Station orbits the Earth at about 330 to 410 kilometers. So technically the International Space Station is still in the thermosphere. Again, like I said before, not a lot of air molecules up there, so pretty much it's the vacuum of space, although technically it is still within the top portions of the atmosphere. This is an atmospheric sounding taken from Albany on July 31st, and every morning and every evening there's a weather balloon launch from Albany's weather station, and as it goes up it records temperature and dew point conditions. It also measures wind speed and wind direction. And as it rises up this morning, notice the temperature actually was decreasing in the lowest level, or actually increasing in the lowest levels of the atmosphere as it was rising up. That's called an inversion, a temperature inversion, and that's quite common when you have clear skies at night and not a lot of wind. And notice the wind's pretty light here, about 5 knots, and it was clear last night, so not a big surprise here that the temperature actually went up as you increased in height. Not something that usually happens in the troposphere. But as the balloon kept rising, that temperature direction changed and it started to decrease with altitude, with some minor exceptions in here, but the temperature kept getting colder and colder and colder as the balloon went up. So down here, this is a 20 degree Celsius temperature line, so the temperature got to about the mid 60s degrees Fahrenheit. And then at that point it started getting colder and colder as it went up. This is the 0 degree Celsius line, so at this point here we went to sub-freezing temperatures, and it keeps going colder and colder until it gets to this point here. Then all of a sudden it starts to warm up a little bit. Well, you'll see on these soundings pretty much at the same level or similar level, you'll see the temperature stop decreasing and actually start to increase. That is the tropopause. That is where you have the troposphere, everything below, separated by the stratosphere, everything above. Now the temperature actually starts to warm a little bit because you're starting to get into the ozone layer, and the ozone layer will absorb ultraviolet radiation, and in the process of destroying it, it actually converts it to infrared energy, and infrared energy is heat energy, and that warms the atmosphere. This diagram is taken from page 14 of your reference table. This is something you have access to for any quiz, test, or regents in the class, so you really don't need to memorize where the troposphere, stratosphere, mesosphere, and thermosphere are with respect to each other, or what altitude they extend up to. It's trivia, but make sure you use this diagram when you need to. But again, just to kind of review what I already mentioned and showed in other diagrams, troposphere is located at the bottom of the atmosphere. Temperature generally goes down as you increase in altitude until you get to the tropopause. Once you get into the stratosphere, the temperature starts going up. As you get through the stratosphere, temperature starts to decrease again in the mesosphere. And again, there's no little sign as you're going up through the atmosphere. You're now entering the mesosphere. You're now, thank you for visiting the stratosphere. How do scientists know, or why did scientists make a boundary between the stratosphere and mesosphere? It's because of the temperature change. Notice as soon as you get a temperature change to the positive side, you're in the stratosphere. A temperature change to the negative side, you're in the mesosphere. And then once again, up here, the thermosphere gets warmer and warmer. Now notice the temperature up here. The temperature is upwards of 100 degrees Celsius or more. That doesn't necessarily mean you will be really hot up there. It just means that the molecules are moving so fast, they have their average kinetic energy can be scaled in at 100 degrees Celsius. But since there's not a lot of molecules up there, they really don't contain a lot of heat energy. Remember, heat and temperature are different. Heat is the total amount of kinetic energy, whereas temperature is the average kinetic energy. So these have a very high average kinetic energy, these molecules do, but there's just not a lot of them out there, which means there's not a lot of heat up there. So don't look at 100 and say, wow, it's really hot up there. There's really not much heat to speak of. There's another chart up here, also scaled on your vertical axis over here. Pressure, notice the highest pressure at the surface, and pressures decrease as you get higher and higher in the atmosphere. Pressure is just a function of weight of the air above you. So as you move up through the atmosphere, there's less and less air above you. There's not as much weight pushing down on you. And it's not just down, it's all around as well. So I have a couple demos that, if I haven't showed you already, I will be showing you on pressure. And then one final one over here, water vapor. The majority of the water vapor, again, near the surface, because that's where it interacts with the hydrosphere of the Earth, the oceans, the lakes, the rivers, the streams. So it makes sense that the greatest concentration of water vapor is near those bodies of water. And then as you work your way up through the troposphere, it decreases. Now notice they do show a little bit of water vapor that gets up into the lower parts of the stratosphere. There are some clouds in the lower parts of the stratosphere, but by far the majority of it is down here in the troposphere. Not a lot of mixing takes place between the stratosphere and the troposphere because of that temperature inversion. A lot of mixing takes place in the troposphere, but not a lot between the troposphere and the stratosphere. That's why there's an imaginary lid that kind of keeps the majority of the water vapor down near the surface.